Okay, hello everyone again. We are back to look at section 7.2, part 2. This will be example 1. So what we are doing with this one is we're taking two separate trig functions. So in this case we have negative 6 sine x plus 6 cosine x. So negative 6 sine x plus 6 cosine x. So what those are is two different individual sine wave or cosine sine waves, trig functions. So for this lesson, we are combining waves of equal period. So you'll notice that what's in parentheses is the same for both of them, and that what's out in front is different. Okay, so our amplitude is different. One is a sine function, one is a cosine function. So these are both different trig functions that we're adding together. And we can use this new addition property that we've learned to figure out how to condense this into a smaller function. All right, so let's go ahead and get started. What we are going to do first is we are going to look at the a sine of x plus theta, and I want to expand that. So normally, all that we've expanded is the sine of x plus theta. All right. So let's go ahead and look at what happens when we expand that. I'm going to leave a little bit of room out in front because we're going to have to do something about that a. We haven't had an a in front before, but not that that makes it difficult. Okay, when we expand sine x plus theta, we have sine x cosine theta plus cosine x sine theta. Oops, I didn't leave myself room. Ooh, I got to leave myself room. Let me go back. All right, I need a little bit of room in front of there. Forgot already. Okay, leave myself a little bit of room, and then I'm going to have cosine x sine theta. All right, so that is sine of x plus theta in expanded form on the right-hand side. But what's happened is we are now multiplying this a out in front. So if we multiply a by this side, what do we need to do to the other side? Well, we also have to multiply it by a. So distributing that through both terms on the right-hand side, this is now what we have, and this is our new expanded version that we are going to use, and now we are including an amplitude for our trig functions. All right, so what we have in yellow, all of this in yellow, this is in expanded form. So if it's in expanded form, then we have negative 6 sine x plus 6 cosine x, and we want to compare these two to what's above it so that we can rewrite that in. All right, sorry about that. I can't tell you how hard it is to make videos with 5 kids running around the house. All right, we are back on track now. Okay, so what I want to do is I want to compare, make it a different color. I want to compare my expanded version. So this part here with this part here is fairly similar. So look at those two parts, compare them, and then compare these parts. Okay? So what I need to do is figure out how to write this in condensed version. So what I notice about both of them is they both have a sine x here. All right? So what I'm going to do is I'm going to cross out that sine x. So what we're really doing, think of it as setting them equal to each other. I just don't want to write all of that out, and we don't need to write all that out. But just think of it as negative 6 sine x equals a sine x cosine x. Okay? Well, if they were set equal to each other, we could divide sine x from both sides, and they would cancel out. Now, I know that we've talked about before how that causes us to lose answers, but that's not really what we're doing in this case. What I am doing is I'm comparing, I'm saying I have a sine x in both of them. So therefore, negative 6 must have to equal a of cosine theta. All right, so see how I did that? I just said these both have a sine x, so therefore my negative 6 is going to have to compensate for all of a cosine theta. Okay, same over here. Now we've got cosine x in both of them, so those cosine x is already taken care of. And what do I know about the rest of my function? Well, 6 is going to have to equal a sine theta. Okay? So now that gives me two equations to work with. Notice I also have two unknowns. What do I want to solve for here? I am trying to find a, and I am trying to find theta in both of them. Okay? I want a and theta for both of those sets. All right, so now let's go ahead and get started. So the first one, to solve for a, that's going to be our first step. All right, I want to go back to my other color. Okay, so solve for a. I'm going to show you a little bit of a shortcut, but I really want you to understand where we get a from. All right, so first thing that I'm going to do is I'm going to square both of those functions. Okay, so I'm going to square both of those equations that I have. So negative 6 squared is going to give me 36 equals a squared cosine squared theta. All right, so that's for one of them. And then I also have 36 equals a sine squared theta. Okay. Now the next step after I square both is I'm going to add them together. All right, and when I add them together, now I'm going to get 72 equals a squared cosine squared theta plus a squared sine squared theta. Now I know it seems a little bit tempting to almost write a 2a squared there, but remember those are both different terms. We have a cosine squared term and a sine squared theta term. So those two we can't add directly down. Okay, but what we can do is we can factor that a squared out. So let's go ahead and factor out that a squared. And then what do we have left is cosine squared theta plus sine squared theta, which of course is our favorite trig identity because it equals 1. All right, so we're going to cross all of that off because all of that goes to 1. Okay, so now what do we have? Now let's rewrite. We've got 72 equals a squared times 1. And then solving that, we have a is going to equal the square root of 72. All right. Now we're always going to just work with the positives on this. We're not going to worry about saying like a is plus or minus the square root of 72 or anything like that. So we're just taking our positive square root of 72. Okay, so that's the first part. Okay, I'm going to erase some stuff here. So I'm going to pause the video for a second and I will be right back. Okay, and we're back. So I wrote up here the important parts of what we got from the last clip. So we have negative 6 equals a cosine theta, and positive 6 equals a sine theta, and then we also, using our Pythagorean identity, solved for a equals the square root of 72. All right, so now from there, we're going to go in and plug in a for both of these. So now we have negative 6 equals the square root of 72 cosine theta. and 6 equals the square root of 72 sine theta. All right, so now I hope you can see where we're kind of going from here. So I'm going to go ahead and solve for cosine theta here. So we've got cosine theta is equal to negative 6 over the square root of 72. And then here I have sine theta is equal to 6 over the square root of 72. Okay, so notice that theta is the same angle, right? It's the same variable for both cosine and sine. I need that theta to be the same for both of my functions. So we know we have two options for cosine. We also have two options for sine. So let's look at this and figure out which quadrant we're going to be in. So if we have cosine of theta is equal to a negative answer, well, our cosine negative over here, it's going to be about here. So we have two options. My answer can either be in quadrant 2 or it can be in quadrant 3. Okay, those are my two options here. For sine, I've got a positive value. So 6 over the square root of 72. It's going to be up here. So for sine, my options are either quadrant 1 or quadrant 2. However, I need my theta to be the exact same for both sine and cosine. So if you notice in our unit circles, this and this here will give me the exact same theta. So when I do these answers, I know I need to be in quadrant 2. So remember this as we go. Our solution needs to be in quadrant 2. Also, I need you to recognize and see this up here. This is kind of the first time that they've done this to us, where we have to have our domain between negative pi and pi. Now, we've talked a lot about negative pi over 2 and positive pi over 2, but not a whole lot about going all the way to negative pi. So that means if our answer is going to be in quadrant 3 or quadrant 4, you're going to have to translate that into a negative angle. Okay, or maybe find the sine first. Now, cosine, my cosine function, I know I'm going to come up with a positive angle when I do cosine. So maybe when we need to be in quadrant 1 or 2, use your cosine first. Okay, and I'll show you a little bit more about what I mean there. And then if you need to be in quadrant 3 or 4, then use your sine and double check what your answer is. Okay, for this case though, our answer is going to be in quadrant 2. Okay, so that's important to recognize and understand where that answer is going to be, because we need to know that our answer is the correct one. All right, so let's go back. So let's go with our cosine. And cosine of negative 6 over the square root of 72. Find the arc cosine. Obviously, you're going to want to use your calculator for that. So when I put that into my calculator, I get theta is equal to 2.356. Now I can run some numbers really quick. Look at what pi over 2 is, right? Look at what pi is. Okay, if you know those numbers good, you can see that 2.356 is going to be in quadrant 2. It is going to be between pi over 2 and it's going to be between pi. So that is a good solution. All right, but I want to check my work. I've got less than a minute left, so I'm going to hurry. Okay, I want to check my work, and to check my work, what I'm going to do is I'm going to plug that theta value in for my sine. So take the sine of 2.356 and check to see if that equals 6 over the square root of 72, okay, which is 0.707. And yes, that does check. So always make sure that those are working for both. Also, let's make sure we highlight our answer. This was our answer right here. So in your MyOpenMath, you need to include the answer A, and you need to include the answer theta. Okay, and that is all we have for that first example. I will be coming up with another example that's going to be in quadrant 3 or 4, And then there's also some minimums and maximums you'll have to look at too. So we'll see you back in just a